So hi, this is Sapita and today we'll be looking into question duplicates using Siamese networks in natural language processing. So in this particular experiment, we'll be learning about Siamese networks and we'll be understanding how triplet loss works. And we will also learn how to evaluate accuracy and how to understand the evaluated accuracy. And we'll be using cosine similarity between the model's outputted vectors. And we'll be using a data generator to get batches of questions and we will use it to predict our own model. So we will start off by importing the data. So the data that we will be using today is the Quora question answer data set to build a model that can identify similar questions. So uh, in popular platforms like Quora, there are like several versions of the same question posted. So it ends up getting several times responding to the same questions but in different regions. So this experiment aims to like find the similar questions and group them together. So the data set is already labeled and this is the first cell that we'll be running. So we'll be loading the data set and do some pre-processing. So then followed by the following cells, they will be looking into selecting only the duplicate questions and removing them so that we will be having a smaller data set. So after removing all the duplicates, we will be splitting our data into training and testing sets, and the test set will be later used to evaluate our model. So now we keep only the rows in the original training set that corresponds to the rows where the TD index is set to be true. And then now after doing all of the data pre-processing tasks, let's see how our data looks like. So this is the training set and this is the testing questions for sample. And finally, after splitting your training set into training or validation set, we can finally use them for training time. And before that, we have to learn how to encode each question as a list of numbers. And we will start off by learning a word dictionary or vocabulary containing all the words in the training dataset, which we will be using to encode each word of the selected duplicate pairs with an index. So the first thing that we'll be doing is using text vectorization layer from Keras, which will be doing all these encoding tasks for us. And then it will split the text on white spaces and it strips off the punctuation from the text. And now we can check how big our vocabulary is. And then we can also call the text vectorization to see what the encoding looks like for the questions of the training as well as the testing sets. Here you can see that the encoded version looks like this. For here, the first question the train said is this one: I'm a Capricorn, Sun, Cap, Moon. So what does it say about me? And this gets encoded, and those encoded questions are showed as output. Then next we are going to define a CMS model. Before defining the CMS model, we have to understand what a CMS network is. So CMS network is a neural network which uses the same weights while working in two different input vectors to compute comparable output vectors. So the CMS network you are about to implement looks something like this. So the first question will be going into the process of text vectorization, followed by embedding happens and it goes through the LSTM model, which is long short-term memory, and then we will be comparing both the question 1 and question 2 based on the cosine similarity, and if the similarity score index is very much less, then it means those two questions are same, so they will be grouped together into a single question, and if they have varying or like too much a dissimilarity, then they are considered as different questions. So you get a question, it gets vectorized and embedded, and it will be running through LSTM layer and normalized to V1 and V2, and we'll be getting the cosine similarity, and based on that we will be like finding whether the questions are similar or not. So first we'll be implementing the CMS function. So this is the CMS function that we will be implementing. So the code explanation is given here. So we are first grouping the linear stack of layers into the Keras model, and then you can pass the layers as arguments to sequential separated by commas. And for example here, sequential embeddings, average pooling, then softmax, they are just like separated by commas. And then we are mapping positive integers into vectors of fixed size. And then the LSTM layer, the number of units should be specified and should match the number of elements in the word embeddings. And then we are doing average pooling, so it computes the global average pooling, which is essential to calculate the mean across the desired axis. And then we are calculating the lambda value, which is the layer with no weights that applies to function f. And then we get the input, and it is used to instantiate a Keras tensor. And then we are concatenating the final list of inputs, and this is how the CMS network is initialized. And then we are checking our model, how it is working based on some visualizations, followed by we are drawing the model for clearer view, which is just for reference purpose. And then the next thing that we are going to do is we'll be using TensorFlow to run tf.math and tf.lin and lg instead of the numpy functions. And then we are using this function, the tf.linalg.matmul, to calculate the similarity index. So this is what we are doing. So we are calculating the triple loss function. So the triple loss function is created using this following piece of code. And then the triple loss function is calculated to an average of 0.70. To recognize that it's a loss function, the Keras needs two inputs, true labels and output labels. So you will not be using the true labels, but you'll just have to pass some dummy variable with size, path size, for TensorFlow to accept it as a valid loss. And the part 3 is training. So now it's finally time to train our model. So as usual, we have to define the cost function as well as the optimizer. So here the cost function and optimizer is being used. We are compiling the model, and as far as we are using the fit method. So this is the training model function, which takes the Siamese networks, the triplet loss value, the text vectorization, the trained dataset, and the validation dataset. We're passing the batch sizes, the learning rate, and the epochs. So we are training the CMS network now, and it's been trained. The part 4 is evaluation. So now we are evaluating our CMS network, and we are classifying. To determine the accuracy of our model, we'll be using like the test data, the Q1 test, Q2 test, and Y test, some of which are duplicates and some of which are not. So we are looping through the incoming data in batch size, and then we split the model output prediction into version 1 and version 2. V1 is the first part of the prediction, and V2 is the second part of the prediction. For each element of the batch, we find the cosine similarity, and based on the similarity, if it is greater than the threshold value, then we will consider them as similar indexes, and if not, we are considering them as different indexes. So now this is the function to classify the given normalized vectors, and we are testing it. Finally, we are completed training a model, and finally we are testing it with our own questions. So the first thing that we are going to do is create a TensorFlow dataset from your two questions, and we use the trained model to extract the V1 and V2, which is the similarity index normalized form, and we are computing the cosine similarity of V1 and V2, and then we are computing whether those two are similar or not based on the cosine similarity index. So this is the function which performs the following operation. And finally, the question 1, when will I see you? When can I see you again? These both questions have a cosine similarity of 0.84, which means those two are similar, which has been identified using this experiment where we identify question duplicates. Similarly, this is another example where the first question is, do they enjoy eating the dessert, and do they like hiking in the desert? So these two questions have different approaches. This one is eating a dessert, which is like a food item, and this is hiking in a desert, which is like an place, a geographical area. So these two are they're not similar, so they have a less similarity score, and the similarity question duplicates turn out to be false. So this is how the CMS networks are used. So CMS networks are generally used to identify cosine similarity, which can be further used for these purposes like question duplicate identification. Thank you.